Hello, today I'm going to be talking about a simple development workflow which I'll show you how to set up in another video using Jenkins as a build server and gitbucket as the distributed version control system. So this is one of those areas which done incorrectly can cause so much pain as a developer. A surprising amount of pain, can make you spend hours just trying to build software and just spend time on things other than coding. So this is just a simple one. It's not like I'm not giving you best workflow or anything like that. Just the concept of integrating a build server with your repository and the benefits you get out of doing that. So you're down here, developer. What do developers do? They create, edit, and delete files. And hopefully if they're a good developer, they also run tests and their code actually compiles. But in the greater perspective, in the project's perspective, you can't see that. Other developers can't see you compiling or running tests. And that is the key thing, is that you don't know that developers are running tests. How can you know for sure? You can't see it. So we're going to get back to that. So after you have got these local files, you commit to your local repository. And you might commit things that you don't necessarily, you're going to remove later or whatever, but this doesn't affect everyone else's repository. And that's the beautiful thing with distributed version control systems, is you've got your local repository and don't upset everybody else when you commit things that are rubbish. So once we don't have rubbish and we're ready to commit something decent, we push our changes to our remote repository. And here's where a lot of variations happen. There could be some lead engineer pulling stuff out of your remote repository into the repository that actually produces your release software. It's not important. It's just that your changes get to a remote repository. That's the thing to remember. And now we want to integrate our build server with this remote repository. So in Jenkins, there's two ways that happens. It's polling and HTTP hook. Now the polling is where Jenkins is looking at the remote repository periodically to determine if there's been any changes and if it should rebuild. And the other one, HTTP hook, is a bit more efficient, but sometimes a bit harder to set up. So like in GitHub, it's quite hard to set up. If you're running Jenkins on a local machine somewhere, then you don't necessarily have, your computer isn't necessarily accessible to the internet, and that's one of the requirements of using HTTP hook. But with Bitbucket, we can do this because Bitbucket will be running locally. But if you're using GitHub, it's hard to set up the HTTP hook because your computer needs to be accessible from the internet. So once we've established the link between the build server and the remote repository, our build server then compiles our Java code into .class files and into the bytecode, and also copies, your PNGs or your bitmaps, etc., pictures, text files, property files, and then in Java. So the next part, running tests. This is one of those things which can vary a lot depending what sort of project you have, where you might run tests after you produce your WAR, your jar. Typically, that's a good practice to do that too. This just depends, but the important thing is we run tests. Now we produce our artifact, which is just a jar or WAR. In the next project I'm going to show you, it's going to be a jar. And then what build servers tend to do is archive at least the latest artifacts. So you can always just go to your build server and download the latest artifact, which is very handy because I've been in places where people say, oh no, it behaves this way, or no, it behaves that way. And so the build server is like the judge of how the program actually does behave. You download it from there and you can run it on your computer and you can see that it's actually indeed running this way or that way. And then you want to publish your artifact given that it's passing the test usually. So you wouldn't want to be publishing stuff that's failing some crucial tests. And this will again depend on what sort of project you have. If you're deploying to a server or you just want to make your jar downloadable from some internet site, that just depends on your project. And so the most important thing the build server does, arguably, is email developers when they fail test or break the actual code. So you can have a lot of variations with this workflow, infinitely many. Another variation you might want to have is that this build server maintains its own remote repository and pulls in changes from this remote repository, given that it passes all the tests and compiles and produces the artifact. And that way you always have this repository that has no code committed which breaks tests and always compiles and produces the artifact. And some of the main benefits you get from this workflow is that you can always check your produced artifact on your machine against what the build server produces. And this is very important, and it solves so many arguments you might have with developers over code that you've committed and code that they've changed, because if you've got it set up for the HTTP hook, or at least polling very frequently, then you're easily going to know who's broken the code, and you're always going to have that repository if you set it up that has the code which is always working, and then you can compare the repositories, etc. There's just so many things you can do with the build server, and it saves so much time. And there are problems that the build server addresses that they're just reoccurring problems in development. So I hope you can start to see some of the benefits of using a workflow like this. Even if you're a single developer, it's worth setting this up at least one time. It's definitely a nice skill to be able to have, is to use one of these workflows. So thanks for listening, and next video I'll show you how to set up with